In today's world, rare earth magnets play an absolutely indispensable role. In a modern car, for example, you find more than 100 electric motors adding up to a total weight of around 1 kilogram. In hybrid or electric cars, 10 to 30 kilograms are needed. And if you look into the newest generation of wind turbines, even up to 2 tons of magnetic material ensure a reliable function. Therefore, the raw materials for these magnets are in great demand. And a lot of research is being put into the resource-efficient production of magnets.
We started working on rare earths way back when they really were rare. That's a bad title, of course, for rare earths because they're not earths, they're metals, and also they're not so rare anymore. I mean, there are many cases of where they are throughout the world.
However, as most of the raw material sources of rare earth magnets today are controlled by China, this puts great pressure on finding alternatives.
The Chinese, of course, have captured the market pretty thoroughly, so there is a strong case for looking at more sources of rare earths.
REProMag has developed a new production method, the SDS process, which consists of 5 steps. The first one is recycling.
So one of the things that I've been looking at in particular is using hydrogen to break down the magnets contained in things like electronics. When the hydrogen goes into the structure, it forms a hydride at the grain boundaries, the structure expands. And then it goes into other parts of the structure and it can't cope with that volume expansion, so the material breaks apart. The material also demagnetizes, and then you can tumble the electronics, which separates the powder plus the nickel coating, and then afterwards, because the material is very friable, because of the nature of the material, you can mill that material down and you can then separate the NdFeB as a powder from the rest of the other components.
Shaping. The magnets are now brought into shape.
This powder can now be used in several ways. You can either chemically separate the alloying additions, or you can use the powder directly to make polymer bonded or sintered magnets. In our REProMag project, however, we take a third, rather revolutionary method. We mix the powder with thermoplastics to form a feedstock that can now be injection molded or 3D printed.
When shaping by injection molding, the feedstock pellets are being put into a conventional molding machine, where the heated mixture is pressed into the die. Complexly shaped products can now be processed in high production volumes. During the process, a magnetic field is aligning the particles, allowing anisotropic magnets or even multipole arrangements without further machining. Debinding. In order to get a fully dense high-performance magnet, the thermoplastic binder has to be removed. This is done in a solvent bath, where the main binder component is washed out. Sintering. The remaining backbone binder, which holds the powder particles just in shape, is thermally decomposed. When heated to the sintering temperature, the large surface energy of the powder particles forces them to build sintering bridges, gradually developing into a fully dense part with its typical aligned and fine-grained microstructure. Using the SDS process, magnets are produced in all kinds of sizes and shapes in a circular material loop, absolutely waste-free, thus offering new perspectives for high-performance magnets.